Hi students, it's Miss Vernon and I'm back today with a new unit. I'm so excited that you're back with us. This unit is going to be like a mini unit. Think of it like a mini series. We have a very quick couple lessons and then we're going to review and test. 1 week, this unit's going to be done. So this unit focuses on exponential equations, which is going to be studying a different type of equation than we studied during semester 1. So today we're going to be learning and focusing on looking for exponential growth and decay patterns. We're going to look at the connection between our patterns and recursive and exponential forms of these different sequences. So in example A, we're actually going to explore the differences between a linear and an exponential equation. To begin, we're going to talk about a linear equation. So a linear equation is an equation that is in the format of y equals mx plus b. So our first task is write a linear equation that starts at 7 and goes up by 2 each time. As we remind ourselves about our linear equation, which of these numbers is going to be the m and which one is going to be the b? Hopefully you remembered that our starting value is the b value, and what we go up by each time is our m. So our linear equation is going to be y equals 2x plus 7. Next, we're going to write our exponential equation. This is a new equation to us this year, and an exponential equation takes the format of y equals ab to the x. I had an old mentor of mine who used to always teach this by saying it's a Yabix equation because it spells Yabix. Now, in the Yabix equation, or y equals ab to the x, the a is going to be our starting value this time. So that would be like your value when x is 0. And the b is going to be what you multiply by. So whatever you would multiply by, that is going to be your b value. So in this case, it says it starts at 7. So 7 is going to be the a in that equation, and we multiply by 2 each time. So that's the b. This equation is going to be y equals 7 times 2 to the power of x. Awesome. Next, they want us to evaluate or find the y value when x equals 10. So basically, we're going to plug in 10 and see what we get out. So I have y equals 2 times 10 plus 7. Y equals 20 plus 7, or y equals 27. That's the linear equation. Let's look at the exponential. When I plug in 10 for our exponential equation, it's basically going to have us do 2 times 2 times 2, 10 times, and then we multiply by the 7. So remember, order of operations says do this exponential part and then multiply by the number up front. For this type of problem, I like to just type it into my calculator. And when I typed this into my calculator, I got 7,168. That's a really large number in comparison to the other one. Take a minute and write down why you think this happened. So how does that look on the graph? Why do you think? So which one grows faster, linear or exponential? Why do you think that is? And how would the graphs look? When I wrote mine, I got exponential equations grow faster because multiplication is more powerful and allows for faster growth. A linear graph is a straight line, where an exponential graph will be a curved line. So again, a linear graph is going to be just our straight line graph that we've seen before. But our exponential equation is going to be a graph that kind of curves and grows like that. All right, let's take a look in a table format. So one of these tables is going to be a linear function, and one of these tables is going to be an exponential function. We're going to write the equation and then evaluate it for x equals 15. So we're going to call this table A, and this is going to be table B. I want you to determine or make a prediction. Which one is linear? Is it table A or is it table B? Hopefully you said table B was our linear graph. The reason table B is our linear graph is as we look at how the graph is changing, I see that the x values are increasing by 2 each time. The y values are decreasing by 10. Now, because we're increasing and decreasing by the same amount, that allows us to find the slope. And our slope in this case is going to be negative 10 divided by 2, which is negative 5. So we know our slope or m value, and we know that the b value is whatever y was when x is 0. So we have an equation of y equals negative 5x plus 60. Now we just have to evaluate it. So we have y equals negative 5 times 15 plus 60. Y equals negative 75 plus 60, or y equals negative 15. Now again, you can grab a calculator and type this in exactly as you see it. So I would have negative 5 times 15 plus 60. There you have it. All right, let's take a look at table A. Table A is going to be the table that's representing our exponential function. Why do you think I can say that this is an exponential function and not a linear function? Hopefully you said something about the fact that these are not adding the same amount, or subtracting in this case. 160 minus 120 is 40. 120 minus 90 is 30. And 90 minus 67.5 is not a very nice number. But it is not consistent. Because these are not consistent, we're not going to be able to say it's linear. That's an indicator it's probably exponential. Now, when determining an exponential equation, you need to figure out the a and the b of the equation. The a value of the equation is always going to be connected to that when x is 0. So we know that in this case, a is going to be 90. Now, to find the b value of a table, it's very important that you follow this trick. You want to find two terms or two y values that come right in a row. I'm going to go ahead and use these two. And what you do is you take the second one divided by the one that came before it. Or in this case, 120 divided by 160. So two numbers that come in a row, like -2, -1, and you divide them. And when I do this division, I got 0.75. Now, I always encourage my students, double check that it's working out. So to check this, I would take 160 times 0.75. And when I do that, I should get 120 out. I do. Now, if I multiply that by 0.75, I should get 90 out. Again, I do. And when I do it one more time, I should get 67.5 out. And again, I do. So in this case, this table was going in order. And each time to get from one term to the next, we multiplied by 0.75. So that means the b value is 0.75. So I get y equals 90 times 0.75 to the power of x. Now it's time to evaluate. So we take y equals 90 times 0.75 to the power of 15 because x equaled 15. Now let's see if I can make this happen here. Don't think my basic calculator on my computer is going to do it. Let's see, can we switch it over? Nope. Still just stays pretty basic. Oh, let's do scientific. This should work. All right, so we have 0.75 to the power of 15, enter. Oh, that's a very small number. And then we multiply it by 90. And when I do this, I get 1.203. So y equals 1.203. There you have it. Y is going to be that value. Excellent work. All right, let's move on to the back side of our notes packet. On the next page of our notes packet, we're going to take a look at some applications. Exponential growth is one of the best ways for us to understand how money works. So oftentimes with these problems, we're going to see money examples because it's how interest works at a bank. So let's go ahead and read this problem. I'm going to highlight some of the key information as we go. So it says Maria has saved $10,000 for her daughter's college tuition. Her bank offered to give her 5% interest each year if she put the savings account at their bank. Create a table to represent the balance of the new account for the first 6 years. So let's go ahead and take a look. We have some guided questions over here to help us as we work through this. Now, because it's a percent or an interest, it implies that this is going to be an exponential equation. So exponential happens when we're dealing with an interest. Our slope or growth ratio is going to be the B value. And so in this case, our B value is going to be, she gets to keep all $10,000, but she also gets 5% more. So I'm going to add on 1 plus 0.05 to give me 1.05. Now, the reason I did the 0.05 instead of 5% is 5% must be converted to a decimal before we can work with it. To convert 5% to a decimal, you take the percent divided by 100, and that's where the 0.05 came from. The reason I added 1 to it is because she gets all of that $10,000 back, but she gets 5% more. Awesome. Now we are ready to write our equation. So our equation is going to be 10,000 times 1.05 to the power of x. All right, so let's start filling in our table. So we have at time 0, she put and invested $10,000 into the bank. Okay. Throughout that year, she had added in interest. And so the interest that she added in, and I'm going to skip that for just a minute. So then if I plug in 1 to my equation, I would take my calculator and I'm going to clear it, and I would have 10,000 times 1.05. And that gave me 10,500. So basically, she made $500 for doing nothing. So the interest added is 500, and her new balance was 10,500. Okay. So then after 2 years, we take our previous answer, or we can actually type it in again. We can go 10,000 times 1.05. Oops, I don't think it liked my parenthesis idea. To the power of 2. And then we multiply that by that 10,000. Sorry, it cleared it. We get $11,025. She is making money for doing nothing. Isn't interest amazing? So in this case, she would have made, because I'm going to subtract off our starting amount, our 10,500, she would have made $525. The reason she made more than just $500 is because she made money on the $500 that she made from the first year. All right, let's keep going, but I'm just going to fill in the current balance. I'm going to skip doing the other stuff because I want to just focus on the current balance. So another way to do this is to always take the previous balance, so 11,025, and I can multiply it by 1.05, and that's going to give me my new balance. In this case, $11,576.25. So notice each time she's making just a little bit more than she did the time before. So I'm going to multiply that answer by 1.05. And I got $12,155.06. Now, I care about that 6 cents. I want that money. So I'm going to keep 2 decimal places always. Again, I'm going to take that answer and multiply it by 1.05. And when I do that, I get $12,762.82 if we round. And I'm going to do it one more time, times 1.05. This time we have $13,400.95, or 96 cents, I guess. Look at that. She made $3,400 by doing nothing, by letting interest put the money into the bank. That's awesome. All right, let's take a look at the last example. Now, same person, our friend Maria, she is working with another place and she still is going to start with $10,000, but then each year she's going to add $550. If she goes with this option, so the bank's like, we're just going to give you $550 each year, nothing extra, just that. What would her account look like? So at time 0, she still is putting in $10,000. After 1 year, they're going to add $550 to her account, and so she would have $10,550. Well, that's pretty sweet. She's starting out with a little bit more than she had the first time. So at the beginning of that next year, she would have $10,550. They're going to add another $550 to her account. And now she has $11,100. Well, again, that's a little more than she had the first time. Maybe the second option's a better option. At the beginning of the second year, she has $11,100. Notice that I take the new balance and that just gets plopped down here to start the next year. Adding $550 more, now she has $11,650. Plopping that down on year 3, she starts with $11,650, adds $550 more, and now she has $12,200. I'm going to continue to do this pattern. If you'd like to pause and do it on your own, go ahead and do that. It's a great idea. $12,750. The start of year 5, $12,750, adding $550 more. She now has $13,300. And let's see where she ends up at the end of year 6. She ends up with $13,850. Now, my question to you is it wise for her to take and use the second option? Or is it better for her to do the first option? Well, before we make this, let's go ahead and just finish filling this in. This is a linear equation, and our slope is going to be 550 because that's what's added each time. So our equation would be 550x plus 10,000. Now, we know that she added money over time, right? So which option is better? If her daughter's in 12th grade, what option is going to be better? Well, I would say option 2, because option 2 gave her more money. But if her daughter's in 7th grade, I would go with option 1 because her daughter is going to get more money out over the time that she has to wait before she would need to use that money for college. All right, friends, this was a great lesson on exponential equations versus linear equations. I hope it makes sense, and I look forward to working with you soon. Bye.